Hello students, very good morning to all of you. From today onwards, we will meet on Google Meet for platform. There will be online discussion with us, so we can understand actually about the stretching, and with the touch with us, we can understand how much students are doing the study and how much students are so much interested to gain the knowledge. This will be our first interaction after you are coming in the T.Y-Vsem chemistry. So the friends, in the last lecture of the drug and dyes, we have discussed about the oxochrome and chromophores. We know that in the practical examination of practical in the laboratory, we have saw that some solutions having part that color and some solutions not having any colors, that is colorless. If you saw the chemical structure of the chemicals that having some color visibleness, we saw that there are some the chromophore or oxochromic group attached to them. This chromophore exochromic group impart the color to the solutions. The best example to understand is the EDTA structures. At the same time, dyes is also the color species that impart the color to the whatever in which it is mixed for the coloration. So dyes are the applied to the fibers in the form of its solutions, and the solubility in a suitable medium like aqueous or organic become an important factor. The presence of solubility group like SO3H, phenolic, OH, etc. increases the solubility of dye. Now we are studying the limitation of the natural dyes. The limitation of natural dyes. Only small amount of the dye can be obtained by processing the large amount of the animal or vegetable matters. Means the process of the getting the dyes from the natural sources is a very expensive process, or it's a time consuming process, and the yield of the product that process is very low. means it will require more energy, more consumptions of the time, and the product will be the less. Less. Next, the dyes are invariably expensive. Dyes are invariably expensive. Natural dyes are not pure and lack uniformity of the equal quality. Natural dyes are not pure and lack uniformity of quality. Their light fastness are properties were poor. Means whenever we are using the natural dyes or artificial dyes, the property is a poor property. Next question. So that's why in maximum cases instead of using the natural dyes or natural dyes is available can easily be obtained. Instead of that, chemical dyes or organic dyes are used or synthetic dyes are used in case of using the natural dyes. Because of these reasons, because it is expensive and the natural dyes are not pure and lack uniformity of quality. And the next important part which push the natural dyes or it remain at the aside because of its fastness property, because it not imparted the good fastness property to the fibers. Poor properties. That's why the synthetic dyes overcome the natural dyes, and nowadays maximum companies are using the synthetic dyes instead of the natural dyes. Next one is the important point, that is the structure and the properties of the wool as a natural fibers, and also explain which class of dyes applied to it. This question included a part wool, and wool is the natural fiber. This part includes which types of dyes we are going to use for the dye tools. Wool is the best natural polymer, and the dyes are best absorbed by the wool. For coloring the wool, natural as well as synthetic dyes can easily used. The wool is the natural fiber, source is the natural, and it is obtained from the natural source. It is obtained from the ships, hair of the sheep, and it is warm in natures, hot in natures, generally used to woven the sweaters. So it is a very expensive one. It consists of the proteins in it, which in turn are composed of polypeptides. It consists of protein units, which in turn are composed of the polypeptides with amino and carboxylic acid and groups and side chains with disulfide group, which keep the main polypeptide skeleton parallel to each other. It consists of protein chain because why it is protein chain? Actually, wool is the hairy structures of the animals, and hair are the made up of the proteins, and that proteins form that hairs. So it is a polypeptide with amino acid, carboxylic acid N group, and the side chain with the disulfide group, which keep them in polypeptide skeleton parallel to each other. The 20 amino acids are present in the polypeptide structure of the wool. 20 amino acids are present in the polypeptide structure of the wool. CS3C double bond O NHCr dash HC double bond O NHCH. We have studied this part in the. We are going to study this part in the organic chemistry. Structure of wool fiber. Amino acid in the wool fiber may contain the sulfur atoms RCHNH2COH. Here is the sulfur. Sulfur is most important because you know that whenever we are using the gel to hair setting the hair, keratin is the protein present in the hairs. That protein is having the sulfur bond. And as we apply this liquid for hair style or hair change, that protein bond is sometimes are become smoother or broken. And as they adjusted, they again form. So these are all about the wool, that is natural dyes. Next is the class of the dyes. The class of the dyes. Wool is a dye with acid dye, acid modern dye, basic dye, and reactive dye. For dyeing process in the acidic solution, acidity is strictly controlled. Wool fiber can be dyed with acid as well as basic dye through the formation of the salt. Wool fiber can be dyed with acid as well as the basic dye through the formation of the salt. Linkage with the amino and carboxylic acid group. Wool dye can also be dyed with the reactive dyes that can form the covalent bond with the available amino groups. The modern dye also used to alter the dyeing ability of the wools. The next point we will discuss the nylon as a synthetic fiber. The structure of the nylons. Okay friends, we will discuss remaining part in the next lecture. Thank you. I will stop here. Thank you very much.